Welcome all, welcome to this lecture of object-oriented programming, and today we'll be continuing with unit 1 and 2. We have almost finished unit 1. We'll be going ahead with unit 2 today. Okay, so mm, let me show the disclaimer first, then I'll start. Okay, so let's start now. Mm, So as I asked the people last time, we had seen strings, string built-in methods, substring methods in character class, and this is all comparing string as well. Yes, that's right. So all these things we had seen last time, right? So today let's go ahead and try to complete some more things. So yesterday in this last session we saw string type, we saw string methods, specifically the length method, caret, concat, to uppercase, to lowercase, trim method. Then we also saw next method of how to read a string from console, basically the scanner class and its next method, the next line method. And then we saw how to compare string using equals, ignore case, compare to ignore case, and starts with, ends with, and contains. All these methods we had seen, right? And we saw some examples of it. We also saw how to extract substring from a particular string. We also saw how to see the index of, I think this was not seen, so let's see this thing. This index, and in index this index method would give you an index of a particular letter. See, so for example, if this is a string, right, and on that string you directly invoke a function called index of, and you say index of O. So you want to find the index of O. So this thing will give you 4. Why? Because this, well, W starts with 0, then E at 1, L at 2, C at 3, and O at 4th location. So this gives you the output as what? Output as 4. Okay. See, this is the new way in which you can directly use the uh, method. Why this is possible? Because this string itself is an object. This, you might say this is a string literal, right? But strings in Java are considered as objects. Okay. So this particular string itself is considered as an object, and you can directly invoke the string method onto this particular string object by saying, check this out, how do we say over here? Here we specifically give the string, then directly use the uh, and we directly use this dot operator over here, and then we say uh, index of the character. So here is the string. This part is what? This part is the string object part. Okay. And after dot, what comes? After dot is the method call. This is the method call that we are making. Okay. You can see you directly call the method onto the string object itself, not on its variable, but on the object itself, on the string literal itself. Okay. So this is possible in Java. Okay. On the string object itself, you are calling the method. You also say welcome to Java dot last index of O. So when you say index of O, it will give you the first index. When you say last index of O, it will give you the index of this O, not not this particular O. No, not this one. It will give you what? It will give you this particular O's index, and that is 9. Okay. Similarly, when you say welcome to Java and last index of Java after location 5, so that will give you -1. Okay. What does that do? Last index of this S and from index, you see, that basically returns the index of last occurrence of the string before from index. So this is from index. Okay. So it should come before. Okay. Before that. So that's why it is not there. See, this Java location of Java is which one? If we check this out over here, it is 0. This w, this welcome, in this welcome, this w is 0 1 2 3 4 5 6 7 8 9 10 and 11. This is 11th location. Which location? This is 11th location. So before 5th location, obviously Java what does not come. That's why it's giving us the value as -1. Okay, understand? So this kind of basically methods you should know and you should try to play with it, right? For example, index of s and from index, then last index of ch and from index. So that will give you what? Last index of ch that we have not used over here. Okay, you can try it out. You can say index of s and from index. So that will return the index of first occurrence of the string s in the string after the from index. See, here it is after from index. Okay, and it will return -1 if it is not matched. So see, here in this index of will return always return -1 if the match is particular is not found, right? And hmm, similarly, when you say last index of ch and from index, see, this from index has two different results. If you say index of ch and from index, right? So this will use the from index to search after that. So it will search for the first occurrence of the character after from index. You see what here it is? It is after from index. And if you are searching for a string and using from index, then also it will search after from index for a particular occurrence of a string. And if you say last index of, in that last index of you, if you use from index, then that will be using, it will be checking for the occurrence of character before from index. Similarly, for this last index of if you are using a string and there you are using from index, then also that will check the occurrence of the string before from index. You see, so when you use index of and from index, right? It is used to check after this from index. And if you use last index and from index along with that, then that will be checking before that will be checking for the occurrence before the from index. Okay. So do try to play with this particular methods. Okay. Let me show whether we can access it or not. Let me just open with the let me open it with the code, and here we will try to run or try to play with that particular program. So which methods have been given? This particular methods have been given, right? Let me just take those methods and let me open string methods 2 is there. Let me take one more program called as string methods 3.java. Okay. Inside this, I just put this and also take this particular code. Which code? This part. Okay. So now here, I'll just take this 3 part and let put it over here. What we'll do with this is we'll use the system.out.println over here. Okay, we'll just use system.out.println. Let's run this part. So you get to see the output. First, the index of O is 4, second, the index of O is 9, and then it is -1. Okay, so now check this out. Let us make some more code over here. Welcome to Java, and let's use this part, index of 2 times and last index of 2 times. Okay, and okay, that is last index of 4 times coming. Okay. Okay. So see, we have what? Index of with character, index of with character, and from index. So we'll say index of character, and then index of with character and from index, right? So here we'll say index of O, comma 6. Okay, let's see that what happens for that. So if we run this particular code, you will come to see that the index of O is 4, but if we say after 6, index of 6, and you give a from index, that from index will check after that. So it has gone to ninth. Yes, this O is available on ninth location. Which O? First, this O's location is given as 4, this one, and then the second O's location is given as 9. Okay, since it is after 6th location, right? If I give after 9, see what happens. If I give it after 9, it will obviously give me, right now it is giving me ninth, but if I say location 10th, and I then try to run it, it will give me -1. You see that? It will obviously gives us -1 because it does not found any O after that location. See that? So here we have this from index. Now let's you make use of uh, last index of. So we say last index of O and last index of O, comma 6. Okay, check this out. Let me just make this two commented and let me run this. So the last index of O will by default be 9. And then if you say last index of O, if you say last index of O with respect to location 6, so what it will do is it will start searching before that 6th location. Which is the 6th location? See, this is 0, 1, 2, 3, 4, 5, and 6. So 6th location is this E. So it will start searching before this E. It will start searching before this E. And that's why this particular O is found, and that's why it gives number 4. Understand? What is the difference between last index of and index of, and that too specifically how it behaves when you add a from index to it, right? So I think these two lines are sufficient to understand, okay, for character. Now similarly you can make more such 4 lines with respect to a string. Okay, what I've done is I've just found out a index of O with the use of index of and last index of, and that also using from index, right, along with the character. Now you can even search for a string similar way. You can try using search for this 2. You can try for searching for this 2. Okay, I can, or maybe any other keyword that is common. Maybe I don't think any character is common. So welcome to, let's say, Java E world, or simply Java E learning. Now I think you will get most of the things. So you can search for letter E, or maybe let's make it as welcome to Java to learn it. Now you can find for string 2. Okay, you can try with this particular program. You can try for string 2. This I will give it to you people. Okay, you try it out. Fine. See here, if I run this again, the output will be 4 9, and the similar, there is some difference in the output. So you check it out what this 17 belongs to. The 17 is of which O, which particular O has it taken, this one or some other O. Okay, fine. So please do explore this part. Let's continue with the next topic now. So this is string methods. Okay, now we have also seen operators, already we have seen, but there are math operations also, right? You people have already seen how to deal with the operators, right? These are arithmetic operators or numeric operators, specifically addition, subtraction, multiplication, division, and modulus operator. Now there are some methods also available in specifically math class that can do mathematical operations. For example, POW, that uses power, so it gives you the operation of power. So when you say math.pow and a comma b, so it will be something like a raised to the power of b. Okay, and that kind of output it will give you. So when you say math.pow 2 comma 3, it will it will give the output as 8. Okay, when you print it out, you see that. This is a math class, and math class has some static methods inside it which can be directly used by like this, by saying math dot method name, math class dot method name. So math is the class name and this POW is the method name. Okay, so you can directly call static methods in this way. In which way? In this way, class name dot method name. So here the class name is basically what? Here the class name is math, that starts with capital M, and the method name is POW. Okay. There are some constants also that are available in math class. For example, the constant is pi constant is available in math class, right? So you can utilize it. And we have already seen numeric literals, right? There are numeric literals that are supported are specifically, it also supports not only integer literal, but it also supports the binary integer literals, octal integer literals, and hexadecimal integer literals also. So to denote these kind of literals, what you use is use 0b or 0 capital B in front of the number to denote it as a binary integer literal. So when you say 0b1111, that will display the number as 15. Then when you say 07777, just a simple 0 will make it an octal integer. So this will display 4095. And then when you say 0x small x or 0 capital X, that will be used to display what? A hexadecimal integer. So when you say 0x FFFX, that represents 65535. Okay, you see this? Basically, integer, supports a particular range, right? And if you want to make an integer literal into a long literal, then we have seen we have to append the letter L to it. So for example, if this is a big literal and it's not supported by integer, then you use L, a capital L or a small L to it. Okay, fine. So we have already seen numeric literals, and you can try this out. You can try printing this numeric literals out and see how it behaves, right? How it appears, right? And we have also already seen floating point literals, and we know that any by default in Java, any number with a numeric point or a decimal point is considered as a double literal, right? So this 5.0, basically here this 5.0 is considered as a double literal or a double value and not a float value. So if you want to assign it to a floating point number, you will have to assign it a value f. So check this out. When you say this, when you say 1.0 divided by 1.3, this, see here we have said it in string, so it will be printed as string only. But here after this plus, we have put this 1.0 divided by 3.0, which basically is a what is a double based division, double values based division. So it will result into a double value. Okay, you can see there are about how many digits? 16 digits. You see, this division has resulted into 16 digits. Similarly, if you want to make it a float division, then you simply say 1.0f divided by 3.0f. You have to attach f at both the places. Why at both the places? Because if you don't attach f at any one place, then it will become a double value, and then the whole operation will result into, again it will result into an double result. Okay. So now the result of this division will result into a floating point result, and this is the value it will give. It will give you about 8 digits of output, whereas a double division will give you about 16 digits of output. This will give you about 8 digits of output. You see, that's the difference between a float and double. Okay. Okay. Then what if you want to use scientific notation? Then you can use scientific notation like this. Suppose this is the notation 1.123.456. You can write it like this: 1.23456 in E2, right? That is by saying that it is multiplied by 10 raised to 2. Okay. Similarly, you can even write it like this. The same thing, the same literal can be written as 1.23456 E plus 2. Okay, e raised to plus 2, that is 10 raised to plus 2. So this 1.23456 multiplied by 10 raised to plus 2. That's what the meaning of this number. Okay. Character literal we have seen, string literal we have seen, right? We have worked with it. We have already seen the operators and precedence and associativity, right? So we'll not go deep into it. Now we have also seen the increment operators, right? We had seen plus plus and minus minus, and these are nothing but shortened operators for incrementing and decrementing a variable by 1. Okay, and we have to make sure that the increment operators are used properly. For example, if you use it like this is called as pre-increment, and if you use it like this, it is called as post-increment. So plus plus where becomes pre-increment, where plus plus becomes post-increment. So there is a difference. See, when you say int j equal to, suppose the value of I is 1, right? And when you say int j equal to plus plus I, so what will happen is this i's value will be incremented, and that incremented value will be given to j. What is that value? That value is nothing but 2. So the value of j will be now 2, and the i's values will also become 2, right? When you say j is equal to I plus plus, so what will happen? The older value of I will be first given, assignment operation will be given the first preference, and then the plus plus will happen. So j's value will become 1, but i's value will become what? I's value will become 2. Okay. So let me make a table out of here. Over here, this is the table, right? And here we have the value of I, and here we have the value of j. Okay. Here we have the value of I, and here we have the value of j. Okay. So now for this particular part, we will say that the value of I is what? Here the value of I has become, i's value has become 2, j's value has become what? J's value has also become 2. For this particular case, what happens is the i's value becomes 2, but the j's value is becoming 1. Okay, i's value 1 is assigned to j, and then it is incremented. Okay. Similarly, for this particular case, what happens? I's value, when we say that I is 1 and we say minus j equal to minus minus I, so basically i's value gets decremented to 0, and the same value gets assigned to j, that is making it 0. And for this particular case, if you say j equal to I minus minus, then obviously j gets the first value, 1 from I, and then the value of I is decremented and I becomes 0. So this is how it is, you see. Okay, so try using this. Okay, try to play with this particular pre-increment and post-increment, and also pre-decrement and post-decrement. Okay. Okay, let's go further. And okay, we have seen arithmetic operators also, assignment operators also, bitwise operators also, relational operators, logical and ternary operators. So we'll skip the operators for now. We have already seen them, but we have not seen the mathematical functions. So let me show you the mathematical functions. There are various mathematical functions available in math class, like math.exp, right? Math.log. You want to make a log base 10, you can say math.log 10. You want to make a square root, you can say math.square root will return you the square root. Okay, let me see, is there any issue? We are giving answer for something. Okay, no issue. Yes, math.square root 4 returns 2. Yes, so these are some mathematical functions that you can use. exp will basically return e raised to power of x, that is e raised to x. Similarly, log x will give you natural logarithm of x. Log 10 will give you returns the base 10 logarithm of x. Then similarly, POV we have seen, and SQRT will return you the square root of a value. So math.square root 4 returns you 2.0. Similarly, math.log 10, that is base 10 with 10 returns 1. Okay. Similarly, math.log and math.e, e is this constant e, and you are making a log of it, it will obviously return 1. And similarly, when you say math.x, exp 1, that is e raised to 1, right? E raised to power 1, that gives you 2.7182. Okay. Now there are some other mathematical functions also which are very much important, and these are very much important. You see math.ceil, math.floor, these are very much important. Check this out, how this works. See, math.ceil, it will take your value up. So right now, suppose that right now the value is 2.1, so it will take it up. So that will become, it will increase it, and that will become what? 3.0. And here math.floor, right? Math.floor will take your value down. So if it is even 2.8 or 2.9, and you say floor, it will take your value down and it will make it 2.0. Okay. Then there is something called as round. Round basically works in this way. See, round, if you say round of 2.3, right, that will take your value up, and that will result into that will take your value down. Okay, so that will take your value down, and that will result into 2.0. But when you say round of 2.6, that returns what? That particularly returns the incremented value and gives you the result 3.0. Okay, and even just 3. So it rounds it. Okay, it rounds it. Here it rounds it to 2, and here it rounds it to 3. That's the difference, you know. So if a number is less than, if a decimal number has a number less than 0.5, so if it is 2.4, right, it will be given as what? When you use it with round method, it will be having an effect of math.floor. So that will be returning you 2. And if you are saying 2.6 is greater than 0.5, 2.5, then that will give you result as 3, which is nothing but the effect of ceil. You see, so this math.round works in this particular fashion. You have to make sure you use round properly, otherwise there might be a mistake if you don't use it properly. Okay, so make sure that math.round behaves according to the number that you have given to it, right? According to the decimal point value, it either gives you the result as per math.ceil or it gives you the result as per math.floor. Okay. And when you say math.rint, that will convert this decimal point number, this floating point number or double number into, into an integer based value but with decimal point. So what it does, it first truncates the number that was after this decimal point and then adds a point 0 after it. So the number in the decimal after the decimal point, all those numbers go to 0. Okay. It is rounded up to the nearest integer. What is it? It is rounded up to the nearest integer. Right. So even if you say r int 2 point, let's say 3. Let me show it to it this. Okay. If you say math.rint and 2.3, then what happens? It will give you what? It will give you the result as 2. Right? It will give the result as 2. Okay. So this is what happens. It rounds it to the nearest integer, but this also gives you what? 2.0. It gives you the result as 2.0. Not integer, rounds it to the nearest integer, but the value returned is double. Okay. So see, most of the mathematical functions return the value as a double data type. Make sure you remember this point. Most of the mathematical functions that you use using math class, those all return the value as double or may even take the input as double. Okay. This functions also see output as double. This functions also output as double. Okay. Then there are some other mathematical functions like minimum, min, max, absolute. So you can find out maximum out of these two numbers. It will return you obviously the double value, okay, and the maximum number. Then minimum number out of these will be returned. Then when you say absolute, it will convert a negative value to positive value. Okay. When you say absolute minus 2.1, that also returns what? A positive value, even if it is double. Yes, obviously it accepts double and gives you double, right? But this absolute may only, it is in the case, in that case, it may give you a value like this. Okay. Okay. So that was about min, max, and absolute. ABS means absolute. Now there is a random method. This is very popular method. You can use this random method to generate a random double value. Remember, it generates what? Random double values. Okay, which is basically greater than or equal to 0 and less than 1.0. It is in this particular range. Which particular range? Less than 0 and greater than, greater than 0 and less than 1.0. So in fact, whatever the number that is written by this method.random is in this range of 0 to 1. Okay, 0 to 1.0. Okay. And so what happens if you want any random number between 1 to 10? Then you simply say math.random into 10. This math.random will give you any number between 0 to 1, right? That it may be like 0.1, 0.3, 0.5, 0.5, 0.56 or whatever it is. You multiply it by 10 and then you convert it into integer. So what happens? The value after decimal point gets truncated and you get a integer that is between 0 to 9. Okay, 0 to 9, not in between 10. Okay, 10 is not there. See, because the value that you get by method.random is less than 1.0, not equal to 1.0, but it may be equal to 0 or greater than 0. Okay, it may be equal to or greater than 0, but not equal to 1.0. So that's why you don't get 10 over here. Okay. Similarly, if you want to return a number between a and a plus b, so and excluding a plus b, then you do something like this: a plus math into random into b. So try this out. These are some of the some of the very much uh, um, popularly used methods to work with random numbers, right? So for example, this is a program which uses it. Write a program for subtraction quiz using random method. Okay, so this is a very good example of using random methods. Okay, fine. So that were those were about operators. Now we'll start with the Unit 2's loops. In Unit 2, we'll see how loops work. Right. So just a minute. Okay. Any doubts? Let me see any doubts. Are there or not? Okay. What are the doubts? Okay, can you explain these math commands with programs? Okay, Harshit, see, these are very small programs. These are very small operations. So I would say you people please explore it out. Okay, I will give you some I will give you. Let me just take this, some of these. Okay, and let me make a new file. I'll say math examples.java. Okay, and here I'll put this. I'll take this main and I'll put it into okay. Now what I'll do is I'll put it into system.out.println. Okay. Fine. And before this, I'll put for every math call, I'll put it. Now see, this math class is available in java.lang library, which is by default available. So you don't specifically need to, you don't specifically need to import it. Okay, so that's why we have not imported it. Check this out. This is math.seal 2.1. Let me run it out. See what's the result? Math.seal 2.1 has taken the value to the ceiling. Even it is very much nearer to 2, it brings the number to 3.0. Similarly, math.floor 2.8 brings the number to 2. So floor means take it down, seal means take it up. You see that? And the result is always, you can see, result is always the double. Then you say math.rint, so it will take you to see this 2.5 takes you to 2. Okay, and if you say, suppose I said 2.7, right? Now I run it. Let's see what is the output. Output will be something like 3. You see, 2.7 is near to 3. So it has rounded it off to 3 and also converted into decimal point. You see that, right? Suppose I make it 3.4, it will again give me value as 3. There it is. You see the third one, the third result is 3. Okay, because it is nearer to 3, it has taken it down. Before it was nearer to 2.7 was nearer to 3, so it took it up. You see, then comes round, math.round. Yes, any doubt, anyone? Yes, someone switched on the mic. Any doubt to anyone, guys? Who has switched on the mic? Yes. Please switch off your mic. Abhishek, you have switched on your mic. If you have any doubt, you can ask. Otherwise, switch off your mic. Okay, thank you. Okay, Harshit, I think I've given you an answer. You would ask, is there any package needed to import such math methods? No, it is available in java.lang package, so you don't need to import it. Okay. Okay. Fine, let me again share my screen. And let me take you to the program. So this is how we use math.seal and math.floor. Understand? See, if I use for method.floor, even if I use it 2.1, it will obviously take it to 2 only, because whatever be the number after decimal point, it does not consider it, and it takes it down. Even it is 2.1, even it is 2.9, if I keep it 2.9, then also the result will be 2.0 only. You see, so it just ignores whatever is the value after the decimal point, and accordingly it takes the value up or down. Okay, and if we see some other functions, then other mathematical functions are this max and min and absolute. So let me show you those also. So for example, when you say math.max 10 comma 20, obviously it will return you what? Let me just comment this out. Okay, and now let me run this. This is giving you what? Result 20. You see, if we give it, if I give it as let's say 10.0, 10 and 10.0, what happens? Let's see what happens. Gives the result as 10.0. You see, if I say 11 and 10.0, what happens? 11.0. See what happens when we gave two numbers, one was integer, another was double. The output got converted into double. The maximum number was 11, right? But the result that came was in double format. So this is what happens in Java. Basically, when you are in mathematical operations, also this thing happens. Check this out. When I say system.out.println, and when I say 10 plus 3, 10 plus 3, right? Let's say 10 plus 3, that will give me an integer result. This will obviously give me an integer result. Okay, this 10 plus 3, here you can see 13. But if I said 10 plus 3.0, and then now I try to run it, it will give me the result as 13.0, you see. So what happens is, this part is integer literal, this part is basically double literal. So what does this plus operator do? It converts this lower data type value into the higher data type value, and then it performs the plus operation. You see that? So it becomes a double addition. It becomes a double addition. The result is converted into double. So that's what happens with arithmetic operator. Make sure that's what happens with arithmetic operators. Let me show you one more secret. This is how you play with the operators. Check this out. So when I say this system.out.println, and I use the same code, same thing, but before this I just put a string saying hello. I just concat it with hello plus 10 plus 3.0. Check this out. What will be the output of this? Guess guys. Please give me a guess. What will be the output of this line? Will it be hello 13.0? Yes. Or hello 10 3.0? What will be the output of this? Can you guess? Yes. Hello, someone is saying hello 13.0. Someone is saying hello 13. Okay, that's good. Okay, so check this out, guys. The output of this is what you might not have expected. So if I run this, the output is, check this out. When you say hello 10, hello plus 10 plus 3.0, in fact, this should become, this thing should become what? This thing should become 13.0, and then it should be added with the string called as hello. It should be concatenated. So this should be the resulting string, but that is not the case. It is hello 10 3.0. So what happens is over here is, check this out, this string comes first. So this string is concatenated with this 10. So this results into what? This results into hello 10. Then what happens? Again a concatenation happens between this particular string and 3.0, right? So that's resulted into what? That's resulted into hello 10 3.0. So it looks like hello 10 3.0. You see that? That's the result over here. So that's why it is always told that please use brackets with arithmetic operations. Take care. So here we use brackets and now our problem gets solved. Let me run it. Output is now hello 13.0. This is what you people expected, right? So the expected thing is always achieved when you take care while using the operators. Okay. Okay, so that is about various operators and various mathematical functions. Someone was asking about round, right? So let me try about round. Let's see this, how this particular function, how this particular output, what is the output of this operation. Here I said 10.3, right? And I'll round it. I say math dot round. See, check this out. Round takes what? Round takes a double or a float as an input, and it can give, if it's a double, it will give you the output as long, and if it's a float, it will give you output as int. That's what the meaning is of round, right? So if I say 10, let's say 10.1 and 3.5, add this to, let it be over here also, 10.1 and 3.5. Okay, I will just remove that. Yes. So let us see what is the result of this. Result of 10.1 plus 3.5 is 13.6, and after addition of that, what happens? That 13.6 is rounded up to 14. You see. So first the addition is happening. First what happens? First here the addition is happening. This results into what? This results into 13.6. So that is rounded off to 14. You see that? That is rounded off to value 14. Now what if I check this out? This is a very interesting thing. If I make it as 3 point, let's say 1 only, 3.1, 10.1 and 3.1, what will be the result? Yes, 3.1 plus 10.1, what will be the result? The result will be 13.2. And when we use it with round, what will be the output? The output will be 13 or 14. Obviously, the output will be 13. So let's check this out. I run this, and the output that I get over here is, you can see, 13.6 is rounded off to 14, right? Let me give a println for this also, so that you can easily recognize the output. Here I'll set 3.1. That's it. So now we run this. Check this out. 13.6 rounded off to 14. 13.2 rounded off to 13. You see that? It gives us integer value. That's what you wanted to know, right? It gives us integer value. Obviously, it gives us integer value. But input, it takes us either float or double. If it's a double, the value goes to long, the literal goes to become long. If it's a float, then the value goes to become int. Okay. Understand? Is it out clear or any other doubts? Yes, guys? Any other doubt remaining? Is there any question have not yet answered? Is it so? Yes. Any question remaining? Tell me. We have seen this, right? We have seen this as okay. I can see most of people are saying no. That's good. So none of the questions are remaining. Okay. So let's continue with the slide. Now let's start with loops. Okay. So loops basically hmm, loops are basically used to uh, continuously run some statements. Okay, so there are basically while loop, do while loop, for loop. So first is the while loop. While loop does what? While loop has a condition in the start. Okay, and then the loop body is there. If the condition is true, if this condition, if this condition, this particular condition evaluates to true, then the control goes inside the loop, or else the control goes outside the loop. Okay. Okay. So, and then there is do while. Do while does what? It first goes into the body. So the statements are at least executed at least once. Okay. And then it checks for the loop condition. So first it executes the statements at least once. The statements are executed at least once. And then even if the condition is false, then also it at least executes it once, because the condition is not checked before. The condition is checked afterwards. So if the condition is false, then it goes outside. Okay. So, there are some various programs like this. This is a sample. Write a program to find sum of numbers entered by user till user enters 0. So what happens is, suppose user is entering numbers like this, 4, 3, 7, say 5, 6, and then 0. So what should happen is, you should start reading it, and as soon as the user enters 0, you should just exit the loop. That's what this program says. So try to use this program, try to make this program. Okay, I'll just give you a hint. I've given you the hint of how this program behaves. Okay, in the loop body, what you have to do is you have to read the number. For reading the number, what you will use the scanner class, right? And which method of scanner will you use? For example, input is the variable, then you say input dot next int. That's the method you might use, right, to read a number, and then you will compare it. In the while condition, you will compare it whether that number is equal to 0 or not. So the condition will be something like this: num is equal to 0 or not. Okay, double equal to, we remember double equal to is used for comparison, not single equal to. Single equal to is used for assignment. So if you say while num equal to 0, that's not a valid statement. This is not at all a valid statement. Why? Because num equal to 0 will do what? It will assign the value of 0 to num, and the result is not a Boolean value. Whereas loops always require Boolean conditions. Java is strictly typed language. So here in this loop condition, only Boolean values are allowed. No numeric values. You see? That's why Java is called as what? Strictly typed language. Okay. It does not allow any numeric value to represent Boolean value. Okay. So try this out. Okay. And for loop is also there, which has got a syntax like this. For first is initialization, then comes the condition, and then comes action after each iteration. If the first it goes first the control goes over here, right? This is the first thing. Then the control goes over here. That is the second thing, and then the control goes. If the condition is true, then the control goes over here. If the condition is true, or it goes directly outside if the condition is what? False. This is the fourth part. So first is initial action, second is to check the condition, third is to execute the statement if the condition is true, fourth is to do the action after iteration, and similarly again now continue from here, it will continue over here. From here it will not go over here. This is executed only once. This part, number one, this number one is executed only once, okay, in the starting. Then after this 4, it will directly jump to the second, and then the cycle will continue. Second to this 3, 3 to this 4, in that way it will continue, okay. So for that, you see, this is an example, it's a very good program. You can write a program for multiplication table, okay. So how do we write that? How do we write that? It's a very, very simple program. I will give you one program for that, okay. One program for loops, and you people would explore with all the other loops, okay. So let me make a new program saying multiplication, or simply, yes, multiplication for loop dot Java, okay. So in this multiplication for loop, we use this public static void main. Here we'll say what? Here we'll say, check this out, you directly start with for loop, and the best part of Java is you do the declaration inside here only. Int I is equal to 1. You don't need to declare I previously. The way we used to do in C, it is not required over here. You can declare a variable anywhere in the program. That's the best part, you see. So for int I equal to 1, I is less than 10, and then I plus plus, or let it be less than or equal to 10. Okay, this is the loop, and inside this loop we make a curly braces to provide its area, and then here simply we say system dot out dot println, and we print I. Okay, not I, but what will we do? We'll print if we want the let's say if we want the table of 2, so we'll say 2 into I. We say 2 into I. So here we will say 2 into I. So on each line we'll get a value of that particular table of 2. So you see this? Check this out. 2, 4, 6, 8, 10, 12, up to 20. You see that? Table of 2 is there. Got it? Yes? Now, what I would suggest is, I'll give you this program, and by the next session, what you people do is, you convert this program into an user input based program. So here I have given this 2. This is hard-coded value. Here I have given this 2 as a hard-coded value, but I want this 2 to be the user given input, right? So if the user says 3, then you should get the table of 3. If the user says 7, then you should get the table of 7. Table should continue up to 10 only. That's fine. Okay. But what you do is, you read this value from the user, and then you perform this. That's the thing that I want to do. Okay. So I'll just right away commit this, and we'll push it onto the repository. You just download it from there and try to edit it. Okay. Any doubts? Please do let me know. Okay. So I'll stop the recording now.